Thank you all for coming today. So we are delighted to present you the results of our work. First of all, I just would like to ensure that everybody can hear me very well. It's okay for you?
Yes.
If there is a problem, don't hesitate to write it on the chat. So this webinar is based on the Work Package 1 outputs of the GEOFIT project, and it aims to provide guidelines to apply IDDS, so Integrated Design and Delivery System, in GEOFIT, but also in European projects. Before I start the presentation, I would like to draw your attention to some rules of this webinar. So just, okay. And so the webinar will be recorded with sound, and it will be available in the GEOFIT website after this webinar. So we kindly ask you to turn off all your micro, and note that the presentation will be divided in 4 parts. And if you have any question, please write them, and we will answer all questions between parts of the presentation or after the presentation, depending on time. So I'm Stéphanie Becker from Nobatek in NetCat, and I speak you from Bordeaux in France. And I will be your pilot today for 1 hour and a half. And the temperature in Bordeaux is about 31 degrees and in 33 degrees in the meeting room. So we are in a good conditions to do this excellent presentation. So I would like also to thank all those who generously helped me to prepare this webinar, in particular Saed Raji, Baptiste Durand-Ested from Nobatek, and also Paul Bonamy, and Gisela from COMSA. And those who will help me to present the webinar today, so Thomas Marsave from R2M, Paul Bonamy from Nobatek, and Sergio Velasquez from IDP, and also people who helped us to organize this webinar, so Marco Caldenori and Veronica, I don't know her name, so sorry. Sorry for your name, Veronica. And so I would like to start by saying a few words about motivation and definition of integrated design and delivery system. So the objective of this webinar will be to provide guidelines to apply IDDS in GEOFIT and other European projects. And first of all, we wanted to raise that current design methods are frequently pointed out for their inefficiency regarding schedule, costs, and management, as we can see with these specific figures. New design methods are promoted, as I will explain later. IDDS is one of these methods. So as you can see, 30% of construction projects do not meet schedule or budgets. Between 7 and 11% of construction costs are spent on rework, which cause delays. 92% of project owners say architectural drawings are insufficient for construction, and 37% of materials used in the construction industry end up being sent to the landfill. So the objective of the IDDS, so Integrated Design and Delivery Solutions, is a high-level collaboration, is to use teamwork together from the early stages of the project to align values and objectives, to communicate effectively, to plan the process, to negotiate a contract, and use BIM to plan and share information. So we have here all the different elements that are summed. So the contents of our presentation will last approximately 1 hour. And first of all, Thomas Marsave will be introducing GEOFIT project and its challenges related to integrated design and collaborative work. Then I will move to the definition and guidelines to apply IDDS in GEOFIT. Next, Paul Bonamy will present how to determine data flow and workflow for GEOFIT. And finally, we will do the transition link from IDDS to GeoBeam together with Sergio Velasquez. We will be taking questions at the end of each part, so feel free to write them on the chat for us to answer. So Tom, please, you can start the presentation of the GeoFit project, and I will move to a different slide.
Yeah, perfect. Thank you, Stephanie. And it's a pleasure to be with you today. I'm Tom Azervi. I'm the coordinator of GeoFit. And what we're doing here is we have a deliverable 1.1 in the project, and we thought, how can we make our own partners more aware of this deliverable and its importance in the project? And then how can we also share this outside of the project with other people? So we're very happy to have some people join our webinar today, and we're very happy to hang it afterwards on our webpage. I'll move very quickly because many of us are already familiar with GeoFit. If you're not, I'm available anytime to talk to anyone about GeoFit. So Stephanie, you can hit the next slide, please. At the macro level, climate change and sustainability, we know buildings consume energy. We know we need to do something about that, and we can't meet targets that we've promised without addressing buildings. Next, please. So geothermal, tapping the underground, is an opportunity. It's always there, and it can deliver significant savings both on heating and cooling. You can go ahead. And because geothermal is such an opportunity, the Commission had a call topic dedicated to geothermal that stated, if we could improve shallow geothermal methods, tools, and technologies, then more people would use it. So there was a call topic. We delivered a response to that, consisting of 24 partners, spanning 10 EU countries. And our response is off to the right in very succinct ways: tools and methods, geothermal systems wrapped into an integrated delivery solution method, and then demonstrating that at exciting pilots in the project. You can go ahead. Here is a look at our partners. We have the full value chain represented there. 5 pilots. Top left, you see a historic building. Bottom left, you see a swimming pool in Ireland. The historic building is in Italy. Top right, you see a school consisting of various buildings in Sant Cugat in Barcelona, more or less. In the middle right, we see an office university structure in Bordeaux. And in the bottom right, we see residential buildings in the island of Arran, which is off the coast of Galway. Stephanie, please. Our concept illustrated in this way, we can think of geothermal in 3 ways: the systems in the house to transfer the energy, the heat pump system, and then the ground heat exchange systems below ground. So below ground, above ground, and then the couplings between those and how to integrate those systems in an optimal way. Next. And we also don't think of just those systems coupled at a point in time, but over the processes which include planning, installation, and then operation. So how can we do smart geothermal across all of its life cycle? Next. And in the project, we made a nice little video. It takes 1 minute, so I think we'll flip through this if the connection allows.
Buildings account for 40% of Europe's energy consumption and a third of its CO2 emissions. To meet ambitious sustainability targets, we need solutions, and fast. Although technologies such as geothermal heat pumps can significantly reduce energy consumption, as they provide environmental energy with low energy input, their uptake is limited by a series of barriers. In response, the EU co-financed Horizon 2020 project, GEOFIT, is developing geothermal retrofitting solutions that are cost-competitive, easy to install, and capable of providing efficient, low-temperature heating and high-temperature cooling. Since retrofitting is a complex process, GeoFit includes new tools and methods, including low-invasive risk assessment technologies, site inspection techniques, innovative drilling methods, optimized design methods, novel technological components, and BIM tools. GeoFit is being successfully implemented in 5 pilot sites in Italy, Ireland, France and Spain. Discover more at geofit-project.eu. GeoFit, smart and efficient geothermal systems.
Great, and thanks once again to COMET for putting together that video for the project. And Stephanie, I think I hand it back over to you.
Yeah, thank you. So now we will speak about the application of IDDS in GeoFit, because as I show Thomas and this very good video of GeoFit, there are very ambitious objectives, and to achieve them we need some collaborative methods and some specific design tools to do that. So in the first part, I will provide a short definition of the most common project delivery methods, and I will provide definition and key elements of what integrated and collaborative project delivery methods are. This will be followed by a state of the art about the main existing methods, and I will provide an analysis of their similarities, differences, and compatibility. Finally, I will propose a general IDDS-based framework adapted to GeoFit. The actors, the design phases, and the collaborative working tools will be defined in a general way in order to be adapted and then applied to each case study. So a project delivery method is the system used for organizing, executing, and completing a building facility, including planning, design, and construction phases. Project delivery methods are used to organize, but also finance the design, construction, operations, and maintenance of buildings and facilities through legal agreements. Generally, a delivery system consists of at least three parties: the owner, the designer, who can be the architect or the engineer, and the contractors. There are many project delivery methods that are existing, and here we decided to present three of traditional methods presented by Design Build Institute of America, and then compare them to another method, which is an integrated project delivery one. So the first one, the Design Build Project Delivery, is a method that is more traditional and dominant project delivery method in Europe and US also, and it has been in use for at least 150 years, and involves three project phases. So the planning, the designing, and the construction. Of course, also the bidding is included, and it has no contractual involvement during the design phase. This is a low-risk contracted method for the owner, as it is the contractor who assumes the financial risk for the construction. However, if design information is incomplete at tender, or if significant variations are required after the contractor has been appointed, the cost of the owner can be significant. Due to its rigid phase system, this design build is not adapted to integrated design. There is another method, the multiple prime contracts project delivery, which has finally the same project phases. The difference is that the owner contracts directly with separate specialist contractors for specific work systems. This method reduces construction costs by eliminating some construction managers' fees and general conditions costs. But due to the separation of contracts, potentially disjointed team can result from this delivery system. And that's why there is another here project delivery system, the construction management at risk, which is particularly well suited to integrated design, as the constructor is involved at an early phase in the project when decisions have the greatest impact on performance. The constructor manager at risk requires guaranteed maximum price from the construction manager if the that is there, you can see there, if the construction manager exceeds this guaranteed maximum price, the owner does not cover the additional costs. But okay, traditional project delivery often involves fragmented teams that work in silos, resulting in linear, segregated, and distinct processes. So major risk is to have an individual management, resulting into a minimum effort for maximum return and yielding outcomes below expectations. And to have a high level of collaboration, the solution is an integrated project delivery. As you can see here, this is a method that aims to involve an integrated team entity early in the process. Because as you can see, all the different actors are grouped into one entity, and they are included in all the different phases of the construction project. As the three parties are involved from the early stage, the design-build project delivery method is adapted for integrated project methods. So the question here is to identify which kind of existing integrated project methods can be used, and especially we did this state of art in order to select the more appropriate method for GEOFIT project. So we decided to present here 5 different methods, which are the main existing integrated project methods. So first, the lean construction. It's a method developed by Toyota for the automobile factory, and it's spreading today in all economic sectors. It is a way to design a production system to minimize waste, time, and effort in order to generate the maximum possible amount of value. The lean construction uses a continuous improvement process that we can see on the right side, which is the plan, do, check, and act, in order to still minimize the lean wastes. There is another method, which is the integrated design process. It's well different from the previous one. It is a collaborative process that focuses on the design, construction, operation, and occupancy of building over its complete life cycle. This method is designed to allow the client and other stakeholders to develop and realize clearly defined and challenging functional, environmental, and economic goals and objectives without risk sharing. The integrated project delivery methods contains many specific components that are here named the pillars on this figure. This method, contrary to the, like the previous one, actually, relies on a high level of collaboration during the project design phase. The main difference is that this method contract includes all stakeholders into the risk and reward structure. At minimum, the owner, architect, and general contractor, which ensures that those who are accepting the risk have a voice in the decision-making, while the previous presented methodology, so the IDP projects, do not require all parties to share risk and reward. So this is the main difference between the two methods. But in addition, contrary to the IDP method, the IPD method and the lean work hand in hand, and many use the terms interchangeably. As we can see, the zero change orders is actually one pillar that is related to the lean management system. So another important method that can be also seen as a tool, depending on his level, is the building information modeling. The traditional processes require 2D representations of technical drawings that now extend to 3D representation and beyond. The extended dimensions that can be captured in the digital interface of the BIM design project can include, for instance, the time in 4D, the costing in 5D, the sustainability 6D, the facility management 7D. There are other relevant concepts that are part of the BIM workflow used for defining the integration aspects and the role of the stakeholders of a BIM project as the project lifecycle, the LOD and OI, which are the level of detail and the development level of information, the roles and ownerships, where the BIM platform can establish and register ownership relationships for each building entity of the project, and collaboration related to the above-mentioned aspect of ownerships. Taking advantage of the digital environment and connectivity also enables these processes to be registered in real time with effective communication advantages. This feature gains more relevance in that it serves as enhanced integration of highly sophisticated disciplines, improving comprehension and integration. So as we can see, BIM is not just a tool, but can be also considered as an integrated method. That's why we decided to include it within the method. And finally, we will go again through the IDDS presentation. And so the IDDS approach is a global method that encompasses the interoperable technologies, the integrated processes together with collaborative people. So we can see there these three main pillars that are very important for the IDDS. The IDDS aims at minimizing the process inefficiencies and at enhancing the value delivered during all the phases of the project by using collaborative work processes and enhanced skills together with integrated data, information, and knowledge management. So typically, the IDDS covers the entire life cycle from the primary conception through the design, implementation, operation, and recycling, and is computer-aided. Building information modeling is an ideal tool for supporting the integrated processes. The interlinkage with BIM reduces design errors, visualizes functional requirements, and can provide location-related information about design detail and knowledge management, and also provides documentation possibilities. It facilitates improved communication between the involved stakeholders. With BIM and related programs, informatic technological tools are available which have the potential to close the gap in good communication. To conclude on these 5 integrated design methods, we have represented here them all together into this figure that show clearly their synergies and complementarity. So the practical involvement of the team is very similar in all the integrated delivery approaches. All the stakeholders equally share the design and management of work. Key participants are involved as early as practicable, and the influx of knowledge and expertise of all key members of the teams enhances the decision making. The lean construction that we can see here at the middle represents the key process change in construction. Also, there is scope for further process development as whole-life design, construction, and operation development. The BIM and the lean construction used together offer a holistic process approach that other industries commonly take for granted. And the BIM used in IDDS as an integral part of the process, while in IDP and IPD, it is only mentioned as optional, as you can see there. So they say it's optional, but they mention that it's a powerful tool to take full advantage of the process. In practice, BIM is typically an integral facilitation mechanism for integrated design process projects, and keeping BIM in view, there is the chance of an evolution, if not to say revolution, of the entire construction industry's approach towards quality and saving resources. IPD here and the lean work hand in hand, like I've already said previously. And IPD sets the terms and provides the motivation for collaboration. Lean provides the means for teams to optimize their performance and achieve project's goal. IPD contracts give all those who participate in the risk and reward structural, while IDP projects do not require all parties to share risk and reward. The IDDS approach, as we can see there, is finally a global method that encompasses all the above-mentioned interoperable technologies, integrated processes, together with collaborative people. So IDDS aims at radically improving the performance of the construction industry and builds upon the recent adoption of new technologies and innovative processes. So new technologies has, for instance, the IFC and the BIM technologies, and innovative processes has, for instance, the lean management, the IPD and the IDP methodologies. Okay. So IDDS was previously presented as a global methodology, and here we will discuss about the just a moment. Okay. The interest to apply it to GeoFit was clearly previously, sorry, the interest to apply GeoFit was clearly highlighted by Thomas, and the IDDS methodology will here be adapted to GeoFit. For instance, especially for GeoFit, due to the initial call for tender from European Commission, European projects are very specific cases and required to adapt IDDS to their context. Phases and actors, as well as project management, can vary greatly compared to a standard construction and architecture project. A particular framework must therefore be adopted and is presented in this chapter. And three main steps will be followed. So the first one is to build the GeoFit integrated team. This step consists to clearly identify the GeoFit consortium stakeholders. So, for instance, not only the members but also the firms, and to pre-qualify them according to their expertise and skills. The next step is to define the main GeoFit project, which is in orange, and to identify their primary roles. This step aims to break the project into phases and to identify the stakeholders' roles and primary responsibilities for each phase. The next step is to develop the collaborative workflow schedule for each GeoFit pilot site. And the objective is to identify local stakeholders, to identify pilot site-specific objectives, to define tasks and corresponding roles of each stakeholders, to define workflow and data flow, and to implement the GeoBIM platform. The four main categories of actors that will act in integrated project approach are the clients, the designers, so the clients in red, the designers in orange, and the constructors, in gray, and managers that are in the middle. Each of these categories integrates different types of actors. They have to collaborate in high level for complying with the same objectives and to be included at the earliest stage. Contrary to new building operation, in retrofitting, clients who can be the building owner but also building users and operators can be consulted and provide the experience feedbacks on the building. They have to be integrated as soon as possible as local stakeholders. Therefore, it's very important to identify them from the beginning, as they are outside the they can be outside the consortium. It's therefore important to define the GeoFit consortium firm that will be in regular contact with this client. So this first step aims to identify for each demo site who is who into the same graph or table, and all the team must have access to this information. For instance, we should identify them and provide email and phone, of course, contact to be able to contact them when it's required. So this section provides a brief summary of each phases in a building design life cycle: the strategic definition, the pre-design, concept design, design development, technical design, construction, building operation, and post-occupancy phase. On retrofitting projects, the strategic definition will be covered with an audit, and in phase 5, the retrofitting project may include only the integration of solutions if there is no objective of extension or complete refurbishment. This is the main difference with the standards construction. An important point to raise there is that in GEOFIT projects, like in most of European projects, phase 0, which is about the strategic definition, phase 1, which is about the pre-design, and phase 2, about the concept design, are already initiated within the grant agreement. So indeed, some technological choices are already done, objectives are fixed, and so on. This particular aspect was taken into consideration into the IDDS framework for GEOFIT. After defining the different phases and the different stakeholders present within the consortium, it is possible to attribute primary roles for each stakeholder and for each phase. This is the first step of the workshop definition that will be presented by Paul. To define the different roles, to identify the stakeholders, and to fix common objectives, it is required to follow a specific collaborative workflow for each GEOFIT pilot site that we already started for each of them, of course. It is constituted by at least 2 important workshops, one with local stakeholders, so workshop 1, that is related to the pre-design phase, and another one, which is the workshop 2, with the consortium only, which is related to the pre-design and the concept design. So, sorry, I just forgot to say that these 2 workshops can be followed by virtual meetings in order to complete the design and to go until the finalization of the technical design and to start also the building operation phase. So, the objective of the first workshop is to imply local representatives who are not in the GEOFIT consortium. So thus they will have the opportunity to influence also the design decisions. It can be completed if required with a specific questionnaire that aims to collect general feedback about all kinds of users of the building. So as it's written, the objective is to establish a communication pathway with these local stakeholders, and of course then to continue this link and to include the local stakeholders into the design and also to gather information on the existing building. So it's also useful for the audit phase. So here we can see an example of a workshop that was done on the pilot site. This workshop had as objective to improve the collective knowledge of the building, and it was brainstorming. So each people had to answer to the question, in this building, I would like to conserve or to improve something. And they had to say which things they wanted to improve and what was, when it was a negative point, they had to write on the pink post-it. And when it was a positive point of the building, they had to write it on the positive, on the yellow post-it. And we also used another brainstorming to answer to the question about their requirements, needs, and targets. So objective there was to raise the expectations of the local stakeholders, and for each different thing, which was the system and emitter, the building envelope, and the comfort, they had to do a synthesis of the ideas selected and grouped by them. So they could, they had just to write their ideas, and then we worked to group them all together. Okay. And so finally, the objective of such a workshop is to improve the collective knowledge of the building, to collect and identify common requirements, targets, and needs. The following workshop, which is a workshop 2, is to establish a communication pathway between all GEOFIT partners to present local stakeholders' needs and requirements, to define together all steps, tasks, and roles of each actor in the 5 different fields that we can see on the figures there. So the building, for instance, the piping, the piloting, monitoring, the ground heat exchanger, and the heat pump system. And it's also, another objective is also to identify missing actors and to point out which tasks will require to additional subcontractors, because all the actors are not within the consortium. And another objective is also to start identifying inputs for each task in order to define the workflow and data flow that will be presented after by Paul. So here is an example of what was done during a specific workshop. Here all partners had to discuss and complete tasks and subtasks with task list for each category. So they had also specific post-it, and they had to complete it for each different category. There was also another session that was that had to objective to complete the first one. So there they had to identify which partners could contribute for which task. And so when the partners was within the consortium, we used a post-it yellow, and if the particular partner that is not identified within the consortium, then therefore they had to write it into a specific pink post-it. And finally, this is the last step where we had just to link the task all together. So here we can see some photos of some workshop that was done in the project. So finally, to continue with virtual meetings, it's required to validate the workflow and data flow, to identify specific working themes, to launch design workshop on working themes, and to finalize technical design, and to start system integration. And to do that, we need web collaboration. So for instance, we can use GoToMeeting, we can use Skype and traditional system like that, but we can also use other systems. So a suggestion could be to use, for instance, the Slack system that could enable to have a very close discussion between all partners that working on the same pilot site. So we can do, for instance, one channel per pilot site. And we could think about specific hackathon for design, like, for instance, the design sprints to work on the specific issues during the project, and to solve very quickly some specific issues in 1 week, for instance. Okay, so now I will let Paul to present the GEOFIT workflow and data flow. And that's all. Yeah.
Okay. So, hello everybody. For the workflow and data flow, so just 1 minute, please. Okay. Okay. So yes, the workflow and data flow, in fact, it's a graphical representation of the process. So here I will explain the IDDS processes through workflow and data flow for GEOFIT projects. And to do that, I will start by, I will explain it in 3 steps. The first is comparing the business as usual versus IDDS methodology. And the second step would be to describe how IDDS methodology can fit European H2020 projects, because as Stephanie said, it's a really specific type of project. And then I will show you a detailed example of the workflow and data flow for the GEOFIT project based on the Bordeaux demo site. So what we can see here, it's the both graphical representation of workflow on the left for business as usual, and on the right for integrated design delivery system. So this graph, in fact, has been adapted from the ones we can find in the literature for new building projects. We can find a lot of literature for IDDS methodology for new projects, but very few for retrofitting operation. So this graph has been built to and adapted for retrofitting project, which is the case of GEOFIT project. So on business as usual, what, I don't know if I can zoom, yes. So to understand a little better the graph, the first line, in fact, is are the project phases. So it starts with the project basis and requirements, in which we can find the audit, the strategic definition, and the program design, for example. Then we have the on-site design. So these are the tasks led by designer team. And then are the on-site installation and test and over. On the first column, in fact, are all the stakeholders and actors of the project. So the first color here of the actors are the clients. They are the building owners and his assistants. It could have the users and operators and public authorities, because they have some requirements and they impose some requirements for the building. And then we have the designer team. Oops. Oh. Comment je peux faire? Sorry. Tac. Yes. So yes. So we have the designer teams, which is the specialized engineers and design company plus architects, and then the construction company. What we can see on the global point of view here is that this workflow is really sequential. So, for example, the clients are working at the beginning of the project for defining the feasibility and the design program, and then after they call for tenders, and the designer teams can answer. The selected one work then for the final design of the operation, and then again we can launch another call for tenders. So to select the constructor. So it's a very sequential methodology, but it's business as usual because it's imposed by the public market law in Europe. On the second hand, we have the integrated design delivery system. So like Stephanie said, it's a collaborative methodology, and so we can see on here that it's more yes, it's totally collaborative. So that means that at the first as the first step, so when the retrofitting is validated, contract between stakeholders are signed at the very beginning of the project to engage their responsibility and define how risk and benefit could be shared. So this is the first step. This is the role of the project manager to engage and to make the contract between all stakeholders at the beginning of the project. And So the sooner they are included, in fact, in the project, the sooner they can participate to the design and minimize the risk for realization. So this way of setting up the project and contracts allow to improve the engagements of stakeholders from the very beginning, and thus to increase the probability of the project success. It's also a good way to share the risk for operation with strong innovative partners, in particular, for example, for GEOFIT project. However, as the stakeholders are needed from the very beginning of the project, it's very difficult to make the selection with tenders and make good competition between the different actors of the market. And that's why this type of methodology is non-compatible with laws for public markets. So on this part, the previous workflow has been a little bit modified to take into account the specificity of European projects. So the fact that for this project there is an initial call from tender from the European Commission, and the client and the funder is the European Commission. The first step, so Stephanie has already talked about that, but the consortium team answer with the contractual document, which is the grant agreement, in which they have to engage their responsibility on innovative objectives and define in a very short time. So at this stage, we can have already the building selected, the technology selected, and the workforce defined, and also the budget defined for every demo site. So it's very important that just after these phases, the next step is to reopen the grant agreement and to share to reopen and to check how the objective could be realized. It has to follow a collaborative work that could be initiated with the organization of workshop like Stephanie presented. So the objective of this first phase is to check that the GEOFIT objectives are really in line with local stakeholder expectation. In the case of GEOFIT, the demonstrators have to be really represented of a good implementation of the technology. So it has to demonstrate that the technology answers very well to the problematic of the building. Then the following steps are very similar to what is proposed in the IDDS methodology on the previous slide. So we have all the work concerning the data collection, and then the data collection and the feasibility studies, and then all the tasks concerning the concept and the design, the definition of specification, with design approval by all the consortium, and then it's followed by the technical design, and then by the manufacturing and the supplying of materials and integration on site. So the detail of these steps is very dependent to the demo site and to the technology selected. So I will present an example based on the Bordeaux demo site. Yeah. So this is about the data collection. I will swap a little bit for the next slide, and I will explain just after. These are from the concept to final design and with the definition of specification. And then from the technical design, the different steps of the technical design, and then with the manufacturing and supply of installation. Yeah. So this is what it looks like when it's all together. What we can see here is that as soon as the objectives are validated by all the consortiums, the design process can start. So the data collection. So the data collection is include, in fact, the information from the site audit, collection of monitoring data, and simulation on energy consumption. So this is what concerns the buildings, but it's also about the actual system for heating and cooling, with the operating parameters of the current energy systems, as well as the site condition, particularly for geothermal application, the surface availability, the underground installation mapping, and the underground installation detection. And then also for geology-related parameters, we have to collect the data about the geohydrology and the thermal parameter, conductivity, capacity, etc. of the soil. Once the data is collected, so we can start with the first step of the concept design, and it will be focused on geothermal study on different parts. The first part is the geothermal study, which include the ground heat exchanger technology selection, and then the thermal hydraulic design with the optimization sensitivity and analysis. And all of this study is included into a design document. So it's quite a similar approach for the other part. For the building envelope, the heat pump and distribution systems, and also the smart piloting and monitoring. So on all this, and in all of this field, in fact, the goal is to include all the design into a single document. And then this document, the design document, is validated by all the consortium, so we can we can go ahead. At the same time, it's very important that the designing steps take into account the local regulation analysis. And after the design document has been validated, we need to ask for the permits, and so this is the big steps. And then after the permit application, if it's obtained, we can continue with the technical design. The technical design will entail in a more detailed design work carried out simultaneously on every technical component of the geothermal retrofitting solution: building envelope, geothermal works, and geothermal systems, heat pump and heating and cooling distribution system, piloting and monitoring systems. So again, it's written into a technical design document that has to be approved by all the consortiums. When it's validated, we can contract with the installer, and so we go with the final steps, which are the manufacturing and the supplying of all the material and the installation on site. So again, we separate into 4 fields, which is the geothermal works, the heat pump and distribution systems, and the building envelope and retrofitting works, and the smart monitoring, piloting and monitoring systems. So these during the installations, the different steps are really linked together, and for example, are dependent from each other. So that's it. It's okay.
And so I go through the last part. We just again because I don't know why we start again. Okay. So we go through the last part, which is about link between the IDDS and the GeoBIM. So first, I will give an overview of the numerical models developed within GeoFit. Then we will define the simulation timeline and the directions, and we will see how to integrate it in GeoBIM platform. And Sergio will speak about the IDDS within GeoBIM. The first step was to list the modeling needs. And so this is the topic of the first figure, which is to list all the systems and their corresponding modeling systems. So in particular in GeoFit, there was some modeling systems for the building simulation, for the heat pump simulation, and also the ground and ground heat exchanger simulations. And there was also specific models, the ROM called ROM models, which is a reduced order model. These models will be embedded in the cloud-based building energy management system, the BEMS, and the ROM aims at modeling the full system, buildings, heat pump, and ground heat exchanger, and it will be used to perform short-term energy demand forecast or to perform fault detection. So the objective was to organize models by design phase, and is organizing models by design phase is to make sure that at each step of the design process, the appropriate model is available along with the required information. So according to IDDS procedure, the following figure describes the main steps, and for each step, a modeling objective is associated. So basic use of the different model will be, for instance, the system sizing, the energy performance calculation, the energy performance verification, the online regulation, the fault detection, etc. And so to define the simulation timeline and interaction, it's needed to list simulations, required outputs, required models, required input data for each major steps according to IDDS procedure. So here we can see all the different need of modeling. So we need to model, for instance, the performance before retrofitting, but also the performance after retrofitting. We need to sort of modeling for the drill selection. We need to determine geothermal system design and performance. And so we need some specific models for fault detection and predictive control. So here we can see also all the different model inputs. So model inputs can be building construction information, weather data, building operational profiles, building indoor temperature, and so on. As we can see there, the orange arrows define when to perform simulation, and the ROM model, which is finally about the building measurement part, will be used and calibrated during the building operation and post-occupancy steps. And for instance, here we can see with the purple arrows that heating and cooling need results. Temperature in the green in the ground heat exchanger computed, and also the heat pump performance efficiency computed will be used for the ROM calibration. Okay. And the set of models developed by the partners will be integrated in the GeoBIM platform. It will allow the platform to configure simulation at each step of the retrofitting project. And this figure is a scheme of model collaboration and the integration with the GeoBIM platform. So the GeoBIM will be used to model the project demo site at all the design phases. It will gather the information about the different models, and it will also store and display the available results. So now I will let Sergio to present the link between the integrated project delivery strategy and the BIM within GeoFit.
Thank you very much, Stephanie, and thank you, Paul. You have introduced very well the IDDS methodology that is very useful for the BIM strategy. As you can see, we can explain a project, an architectural project, in this case a retrofitting project, in three main levels: the physical execution, the integrated design and delivery solutions, and finally the GeoFit platform. We will take advantage of the information produced in each stage of the project development, since the design, since the definition, until the delivery of the final works. In the lower line of this slide, you can see all the different stages: building analysis, on-site design, detailed design, construction, installation documents, tendering, contracting, everything that we need to use during the life cycle of the retrofitting project. These stages obviously produce huge amounts of information. The idea is that by using BIM methodology, we can convert and use the information in open standards in order to implement a platform that can show information, available information, with the help of 3D modeling. That's the main idea. So a project like GeoFit is a very nice opportunity to demonstrate this link between IDDS methodology and BIM methodology, coming from a real-life retrofitting project. In the line between GeoBIM platform and integrated design and delivery solutions layers, you can see the same stages, but summarized in four pillars applied to the GeoFit project. We are starting from the geothermal systems and site design in general terms. Then we have to analyze the standardization levels of the models and designs in order to state the information exchange requirements. It is very important because we have to state the level of detail of the information available in order to be compatible with the GeoBIM platform. Then, if it is needed, some of the information available without the standards can be translated, but at the end, we need to, the information is in the industry foundation classes standard, which is the methodology we are applying by using BIM methodology. At the end, we can build and have available all of the BIM models, which will be implemented within the GeoBIM platform. At the end, when the project ends, we have the retrofitted building, and in parallel, a digital twin by using the most recent definition of the BIM models, like a BIM environment. When a part of viewing the model of the building, we can also update information regarding the performance of the building, any kind of information about the monitoring processes or adjustment that the building requires during the life cycle of the technology installed within the GeoFit project. Please go to the next slide. We also have demonstrated that IDDS methodology is very useful to produce the BIM execution plan. This is one of the basic tasks made by using the IDDS produced by Nobatek in Work Package 1, and we have translated this methodology within the BIM execution plan methodology. Up to now, we have made the different stages and phases of the project as defined, and we have implemented this BIM execution plan in order to follow all of the phases stated by Nobatek. We also have to use the same philosophy by defining the roles and functions of the different partners. As Stephanie mentioned before, we also have to include, in case we have to go to external actors, to introduce the role within the project execution. So in parallel to the physical execution, we can follow the virtual execution of the project by applying this BIM execution plan. The BIM execution plan has been designed for the different demo sites within the project, and depending on the level of detail of the information available from the different demo site owners, we are able to produce in more detail a suitable GeoBIM platform to collect all of the information about the different demo sites. At the end, we will have available a very cool operative platform that can be used to manage the final delivery of the systems installed within the different demo sites in the project. For my side, this is all.
Okay. Thank you, Sergio, for this transition that was very good in line with the IDDS method. So to conclude and before to ask your questions, I just wanted to mention that if you want to learn more about GeoFit and IDDS, you can consult the three deliverables that was produced within the work package 1 and that are public deliverables, so they will be available publicly. And you can also get more information on the website, and in particular this webinar that was registered will be communicated online. Okay, so what I suggest is that if you have any questions that get after this webinar, don't hesitate to send us an email with your specific questions, and we will answer it. And so I think that now we can close the webinar, as we have no comments and no questions. I don't know if you agree with that, Thomas?
Yes, of course. Thank you, and good afternoon to everybody. Bye-bye.
Thank you very much.
Okay. Thank you very much. Thank you, everybody. Bye, and have a good day.